Hello all, I Dr. Nidhi Sharma from AISSMS Institute of Information and Technology Pune. Welcome you all for today's series which is corrosion science. In corrosion science, already we have discussed the mechanism of dry corrosion, wet corrosion, factors affecting the rate of corrosion in my previous videos. Now in today's lecture, I am going to discuss about the how to control the corrosion. So methods of control, corrosion control. The corrosion can be controlled with the proper designing and the material selection. It can be done by the modification of environment. It can be done by the application of inhibitors like cathodic and anodic inhibitors, and it can be done by the cathodic and anodic protection. So, like cathodic and anodic protection, this part is in syllabus of SVP University. In cathodic protection, again it is of two kinds, sacrificial protection and impressed current protection. And then it can be done by the coating, different coating like metallic coating, non-metallic coating and powder coating. So we are going to discuss the few methods of corrosion control. So first method is the cathodic protection. Now what is actually cathodic protection? As it is clear from the name, we are protecting the metal by making it as cathode. So in electrochemical corrosion, anode is the one which undergoes corrosion and cathode remains protected from corrosion. So in cathodic protection, the metal to be protected is forced to behave like a cathode. This is very important. Matter to be protected is forced to behave as a cathode. So that's why this is called cathodic protection. This cathodic protection is of two type. Number one, the sacrificial anodic or galvanic protection. This is called sacrificial anodic protection or galvanic protection. So how it is done? The cathodic protection can also be achieved by more traditional way through sacrificial protection. So how it is done? When two metals are electrically connected to each other in an electrolyte like sea water, the more active metal supplies the current and dissolve at sacrifice to effectively protect the metal. So the metal to be protected from corrosion connected to more anodic metal, commonly used like magnesium, zinc, aluminium or alloy. As you can see, it will be clear from the picture. Suppose if there is a iron pipe underlying the soil. So now as it is in ground, below the ground, definitely the corrosion is going to happen. The corrosion will occur. So what we can do, how can we protect this iron pipe? This iron pipe can be connected with the help of insulated copper wire to the sacrificial anode. In sacrificial anode, what will be there? There will be a presence of magnesium, aluminium, zinc or their alloy, any of the metal, because the reactivity of these metals is more than iron. So what is going to happen? Instead of iron, these metals are going to sacrifice and will protect this iron. So that's why it is called sacrificial anodic protection. So here forcefully we have made this iron pipe as a cathode. Now, what is the advantage of sacrificial anodic protection? You need no external power. It is very easy to install and anodes can be readily added. Minimum maintenance is required. Minimum cathodic interference problem. So, these are the advantages. What are the limitations? Limited to driving potential, limited current output, poorly coated structure may require many anodes and it can be ineffective if very high resistivity environment is there and installation may be expensive. Where it is applied, buried steel pipeline, underground cables, marine structures like ship hulls, piers, water tanks, it is applicable over there. Now, in this cathodic protection, the second type is impressed current method. The corrosion occur in metal depending on the environment to which it is exposed. So the corrosion current always flow from anode to cathode, that we know. In impressed current method, the cathodic protection and impressed external current is applied in the opposite direction to the metal to nullify the corrosion current. As the corrosion current takes place from anode to cathode, so what we will do, we will supply the external current and which will be in the opposite direction of the corrosion current. corrosion. Direct current is applied to opposite direction to nullify the corrosion current and convert the corroding metal into from anode to cathode. See, this is a picture from which it is clear, like suppose if there is underground pipeline. So, and this is graphite or stainless steel and it is kept in the backfill, the insulated wire, and now these both are connected to the external DC source and the negative terminal of the DC source is connected to the iron pipe which we want to protect. So, as it is connected to the negative terminal, so now it is going to work as cathode and this is going to work as anode. So, as forcefully we have made it cathode by impressing the current. So, that's why this method is called impressed current method. So, means current is required in this method. Now, what are the advantages? Large structure can be protected from long-term operations, can be designed for very wide range of current and voltage. It can be applicable for high resistivity environment, effective in protecting uncoated and poorly coated environment. Limitations, the limitations are it can cause cathodic interference problem. Periodic maintenance is required, external power is required, overprotection can cause coating damage also. Where it is applied on open water box cooler, water tanks, buried oil and water pipes, condenser, transmission line, marine pipes, laid up ships, all over there it is applicable. So mainly as we can see what is the basic difference between cathodic and anodic protection. So cathodic protection methods applicable to all metal and this is applicable only for those metal which is. Now second type is anodic protection. What is the principle? In this method, what is important? The metal to be protected, make it more anodic by passing DC in the direction of corrosion current. Means we are doing just reverse of the cathode. The metal which is anode, we are making it more anodic by passing the DC current in the same direction. As a result, the oxide film is formed which protect the metal from further corrosion. But what is important? This is only applicable for the metals which form the passive layer of oxide like aluminium, chromium, nickel, titanium. For those metals it is applicable. The potential state is adjusted as I will just explain with the help of the diagram. As you can see here, the potential state is static. And here, like suppose if it is a metal tank which is to be protected, it is anode. Suppose if it is made up of aluminium, then what is going to happen? We will connect it to the anode of the potential state. The another auxiliary electrode is added that is going to work as cathode. So what we have done, we have made the anode more anodic. So immediately there will be a formation of the protective oxide layer around it, and we know this oxide layer is going to work as a barrier for further corrosion. So the whole metal will be protected further. So, the potential state adjusted for particular current and potential so that the anodic metal tank get oxidized and passivated. So there is a formation of thin corrosion oxygen layer which protect the metal from further corrosion. So once the metal become passive, potential changes to high positive value and current reduces. Advantage, method can be applied for the severely corroding medium like concentrated acid. It required low current density, hence its operation cost is low. Now what is the limitation of this? The limitation of this is it is applicable for those metals only which have the passive nature after the formation of oxide layer. During anodic protection, it takes place in a very small amount but not zero. The anodic protection takes place in very small amount, but it's not like that there will be a zero corrosion. Where it is applicable, chemical reactors, tanks, pipes carrying corrosive liquid, pipes carrying concentrated acids. Now this is the final comparison of cathodic and anodic protection. What is the difference between cathodic and anodic protection? This method is applicable to all metals. Anodic, it is applicable only for the metals which are passive in nature. It is used for metal protection in less electrical conductance medium. It is in more conducting medium. Installation cost is low. Installation cost is high. Operation cost is high. Here operation cost is low because we need a less current. If system goes out of control, the rate of corrosion is slow. But if here the system goes out of control, the corrosion rate will be very faster. The feasibility cannot be predicted by lab experiment. Here the feasibility and design can be predicted by the lab experiment. Thank you so much.